Okay, hi, my name is Arushi, and I'm presenting about CAR T cells application in autoimmune diseases. So, my mentor was Michael Martinez, and I'm talking to you from Colorado. But I chose to research this topic because I've always just been really interested in autoimmune diseases. And I just think like they're the most intense form of betrayal, but we'll talk about that in a second. But CAR T cells seem very promising. So, in order to understand my research, I think you first need to gain a basic understanding of autoimmune diseases. So, in the past, you might have heard that the immune system doesn't know the difference between your body and a foreign threat to your body, and that's true because even though your immune system is supposed to protect your body by attacking viruses, sometimes an error occurs, a miscommunication occurs, where an immune cell attacks a part of the body itself. And that is when you have an autoimmune disease. So we have the notion that our B cells and our T cells, which are just certain types of immune cells, they can turn on us and they can get confused and start attacking us. So when those cells attack the body, they release a small protein called an autoantibody, and doctors can see that in a blood sample, and that's how they diagnose it. But some examples you might have heard of type 1 diabetes, systemic lupus erythematosus, and also like rheumatoid arthritis. The body is just attacking different parts of itself in those. And in the past, autoimmune diseases have been considered incurable because once one bad cell is made, it multiplies, and scientists believe that there's really no way you can get it to stop. But that is until they started exploring CAR T cell therapy. So, this treatment was originally developed for blood cancers, but scientists are currently exploring its application in autoimmune patients too. But essentially, what they do is they can make cells in a lab that attack literally anything they want. So, they've been using this to target like disease-driving cells. And the process starts with collecting a patient's blood sample right here, and they filter out the T cells with leukapheresis and elutriation, which is basically just fancy words for like filtering out the blood. And then scientists inject a gene in the cell that modifies it to target what they want. And after that, the patients usually have to undergo lymphodepletion, which is a type of chemotherapy, just to free up room in their body for the new cells. But once that's over, the CAR T cells can be multiplied and they are re-injected back into the body. So CAR T cells work just like natural T cells. So if you look at this diagram over here, you can see that every T cell has a receptor on it, which is like this tiny part. And the receptors are very important because they're like the T cell's eyes. So the T cell is swimming around in the blood, and the receptor is the part that looks for the cell that it's supposed to kill. So once it finds the cell, the receptor binds to it like this, and then the T cell produces material that convinces this cell to kill itself. And when scientists make CAR T cells, they just change the small receptor part, but they leave everything else the same. So, like in this picture, this is the cell that they take out, and then they make this like CAR construct. The chimeric antigen receptor is what it stands for. And then the CAR T cell like shows these receptors and they can attack the bat cells. And there is evidence to show that like once a CAR T cell is administered, a patient gets an entirely new set of cells, which is like this naive B cell population. And that's why CAR T cells are so useful because traditional therapies for autoimmune diseases like rituximab, it just focuses on suppressing the entire immune system. So you end up immunocompromised. Sometimes it doesn't work. You have to take it for the rest of your life. But what the CAR T cells do is they just remake your entire immune system, so you only have to get it once, and a lot of patients achieve long-term remission. So, as CAR T cells evolve, scientists have been able to experiment with different designs, and these are the five major types of CAR T cells. So, the first type is known as a CAR T regulatory cell or a CAR Treg, and these cells are derived from a specific type of T cell that is less angry than the others, and it acts in like a peace mediator instead of a killer. So, as a result, instead of killing the cells, CAR Tregs simply calm down the immune response so that the body attacks itself less harshly. And even though this therapy does not necessarily eliminate all the bad cells, it's a good option for patients who want to slow down the progression of their disease without facing all of the risks associated with the other types of CAR T cells. And then the second type of CAR T cell therapy is specific for autoimmune diseases, and it is known as chimeric autoantibody receptor T cell therapy. So the auto part of this title comes from the fact that these cells only target the self-destructive immune cells rather than all the immune cells in the body. So the harmful cells are identified by their autoantibodies, or like the parts that attack the human organs. But scientists are still working on finding and naming some of those autoantibodies. So as a result, CAAR T cells can only be made for the most simple types of autoimmune diseases that we have already done a lot of research on. But that brings me to the third type of therapy known as compound CAR T cells, which are designed to attack more than one antigen at a time. So they're most useful for autoimmune diseases that take multiple pathways and are more difficult to like fully pinpoint the exact cause of. And a similar therapy is T cells redirected for universal mediated cytokine mediated killing, or TRUCs for short. But they don't only attack the bad cells, they also release a protein called a cytokine that changes the entire disease microenvironment. So TRUCs can like essentially recruit other cells in the environment to help fight the autoimmune disease. So they're very intense, probably only for like the most rapidly progressing autoimmune diseases in comparison with the CAR Tregs, but they're also very risky. And finally, the last type of CAR T cell is an allogeneic CAR T cell, which is like a donor-derived CAR T cells. So instead of making individualized CAR T cells for every single patient, which can be very time consuming and expensive, we might be able to just collect T cells from like a healthy donor and turn them into a stock of universal CAR T cells that anyone can use. So it would simplify the process, but it comes with intense risks, especially because the body rejects anything that it recognizes as a foreign cell as like one of its mechanisms to protect itself. And that's also part of the reason that scientists have to be so careful about like organ transplants or matching up blood types during transfusions because the body will start attacking anything that it sees as a foreign threat. So we would have to be really careful with allogeneic CAR T cells, but they would revolutionize the therapy. And like any powerful therapy, CAR T cells come with some risks. So the first is called cytokine release syndrome, or CRS, where the immune system reacts too strongly and floods the body with inflammatory signals. So patients can develop fevers, fatigue, and like blood pressure, which is really dangerous. And then another thing that patients can develop is cytopenia, or low blood cell counts. You may have heard of these in the past, but the lymphodepletion, the therapy that they take to like free up space in their immune system, it can mess with their blood counts and it can cause fatigue, infections, or bleeding. There are three types of cytopenias. One is anemia, which is low red blood cell count, and then leukopenia is low white blood cell count, and thrombocytopenia is low platelet counts. And finally, lymphodepletion toxicity in general is a concern because the chemotherapy drugs used before an infusion can damage the organs and leave patients immunocompromised for a long time. So, researchers are working on ways to make these side effects less severe, like using low intensity preconditioning or designing safety switches, but it's still a giant risk and maybe might deter patients from seeking the therapy. So CAR T cells look very promising for autoimmune diseases, so scientists are looking for ways to make them more accessible and effective. And one of the ways this can be done is finding those disease-specific antigens, like for the CAAR T cells, so that the scientists know exactly what the CAR T cells need to be made to attack. Also, like I was saying earlier, we can explore a lot into the allogeneic donor CAR T cells to simplify the process, but we need to prevent graft versus host disease, which is the fancy term for when the body attacks something that is foreign. And something that would make CAR T cells a lot safer is if we can make drug-inducible suicide genes. So basically, scientists would just monitor the patients after they receive the CAR T cells, and if it looks like something is going wrong because of the cells, we can give the patient a type of medicine that would shut off all of the CAR T cells and prevent that problem from getting worse. And this would ensure safety, and it would also probably make patients feel a lot better knowing that they can basically like walk out of the therapy whenever they want to if it's not going the way they like. And that is all I have. Thank you.
Wow, that was wonderful, Arushi. Oh my goodness. I learned so much and very just well stated, well said. Your research was this was incredible. Thank you so much for sharing this. We do have a couple questions for you from the audience. So let me start. The first one is what drew you to this research? Somebody just wants to know how you got it, how you got into this topic.
So I know a lot of people who have autoimmune diseases, and it's always been like a big part of my life. So I've always just been very interested in it. And I first learned about CAR T cells because my science teacher was talking about them. Her daughter had cancer, and she was talking about how like this therapy seemed so promising to like help cancer treatment. So I looked into it and I was like, wait, like they're looking into applying these for autoimmune diseases too. And I fell down a rabbit hole. It was so interesting to me. So yeah.
Awesome. Love that. When you have a personal passion or a personal connection to it, it's always so much more important. There's another question for you. So you mentioned the risk of CAR T therapy. How do doctors decide if it's worth trying for a patient with severe autoimmune disease?
So I feel like it just comes down to the severity of the disease and whether or not they respond to the other therapies because they do have like complex steroids and surgeries and so many different ways to treat autoimmune diseases. CAR T cells are kind of like a niche last resort option for patients who have severely like rapidly progressing autoimmune diseases that like just do not respond to any of the other types of therapy that it could.
Thank you. And then the last question just came in is based on your research, which autoimmune disease seems to respond best to CAR T cell therapy?
Yeah, so some autoimmune diseases are B cell driven and some are T cell driven. And the B cell driven autoimmune diseases release more diverse proteins. So the T cell mediated autoimmune diseases, like I was talking about systemic lupus erythematosus, they respond much better to CAR T cells than the B cell mediated autoimmune diseases, which are like type 1 diabetes, Sjogren's syndrome, arthritis, things like that.
Awesome. This was absolutely wonderful, very informative. Thank you so much, Arushi.
Thank you.